When calculating branch circuit loads for a computer lab, specifically one with 30 desktops in a single classroom, it is indeed a requirement to use 125% of the nameplate rating. This requirement is outlined in the National Electrical Code, specifically in the 2023 edition, Article 645.5 BONIB. This section of the code addresses branch circuits that supply multiple computer receptacles and serve a total of more than 10 personal computers. The minimum load calculation in such scenarios shall be 125% of the connected load. This 125% factor is crucial for several reasons. Firstly, it accounts for the continuous nature of computer operation. Computers, unlike some other types of electrical equipment, are often used for extended periods without being turned off. This sustained usage can lead to heat build-up and increased current draw over time. Secondly, the 125% factor provides a safety margin to prevent overloading the circuit. Overloading can cause the circuit breaker to trip, disrupting operations and potentially damaging equipment. In more severe cases, it can even lead to electrical fires. Thirdly, it accommodates potential fluctuations in the computer's power consumption. While the nameplate rating provides a general indication of power usage, actual power consumption can vary depending on the tasks being performed. For example, a computer running a demanding application or processing large amounts of data will draw more power than one that is idle. To perform the calculation, you need to determine the nameplate rating in amps for each computer. The nameplate rating can usually be found on a sticker on the back or bottom of the computer. Once you have the nameplate rating for each computer, you can calculate the total connected load by adding up the individual ratings. After you have the total connected load, you multiply that total by 1.25, which represents the 125% factor. The result is the minimum branch circuit loads that you must use when designing the circuit. For example, let's say that each of the 30 computers in the lab has a nameplate rating of 2 amps. The total connected load would be 30 computers times 2 amps per computer, which equals 60 amps. To determine the minimum branch circuit load, you would multiply 60 amps by 1.25, which equals 75 amps. This means that the branch circuit supplying the computer lab must be rated for at least 75 amps. It is important to note that this is just the minimum requirement. In some cases, it may be necessary to use a larger circuit to accommodate future expansion or to provide additional safety margin. In addition to the 125% factor, there are other factors to consider when designing branch circuits for computer labs. These factors include the type of wiring used, the length of the circuit, and the ambient temperature. It is important to consult the National Electrical Code and other relevant standards to ensure that the circuit is designed and installed safely and in accordance with all applicable regulations. The NEC Article 645 covers information technology equipment. It provides specific requirements for power, grounding, and wiring of IT equipment areas. These requirements are in place to minimize fire hazards and ensure safe operation of sensitive electronic equipment. Article 645.3 covers the supply circuits and interconnecting cables. This section dictates that all supply circuits and interconnecting cables must be in accordance with Chapter 3, except as modified by Article 645. The power supply cords must be flexible cords listed for hard usage, and the equipment must be connected to the branch circuit through a listed attachment plug-in receptacle. Article 645.4 covers the disconnecting means. A disconnecting means must be provided to disconnect all electronic equipment in the information technology equipment room from the power supply. This disconnecting means must be readily accessible and located at the principal exit doors or in the immediate vicinity of those exit doors. A second disconnecting means can be installed if it disconnects the conditioning system in the room. Article 645.5 covers the branch circuit conductors. This section dictates the calculation of branch circuit loads. The branch circuit conductors must have an ampacity not less than 125% of the total connected load of the equipment and must be sized to prevent voltage drop from exceeding 3% at maximum load current. Article 645.10 covers grounding. All exposed non-current carrying metal parts of information technology equipment must be grounded in accordance with Article 250. This includes equipment frames, enclosures, and any other metal parts that could become energized. Article 645.11 covers marking. Each unit of information technology equipment must be marked with its input voltage, current, and power requirements. This marking must be readily visible and accessible. When designing and installing electrical systems for computer labs or information technology equipment rooms, it is crucial to adhere to these NEC guidelines to ensure safety and prevent potential hazards. Remember to always consult the latest edition of the NEC and local regulations for specific requirements and interpretations. The NEC provides tables for conductor ampacity, such as Table 310.16, which provides ampacity ratings for insulated conductors rated up to and including 2000 volts. When sizing conductors for a computer lab branch circuit, it's crucial to account for the continuous load and apply the 125% factor, as mentioned earlier. Overcurrent protection devices, such as circuit breakers or fuses, must be selected and installed to protect the branch circuit conductors from overloads and short circuits. The overcurrent protection device rating should not exceed the ampacity of the conductors it protects. NEC Section 240.4 provides requirements for overcurrent protection. Grounding is a critical aspect of electrical safety, and it's essential to ensure that all computer equipment and metal enclosures are properly grounded. A grounding electrode system, as outlined in NEC Article 250, must be established to provide a low impedance path for fault currents to return to the source. Surge protection is also recommended for computer labs to protect sensitive electronic equipment from voltage surges caused by lightning strikes or other transient events. Surge protective devices, or SPDs, should be installed at the service entrance and at the branch circuit level to provide comprehensive surge protection. When planning the layout of computer receptacles in the lab, consider the spacing requirements and the number of computers per receptacle. Avoid overloading individual receptacles and ensure that the receptacles are readily accessible for maintenance and replacement. Proper ventilation and cooling are essential in computer labs to prevent overheating and ensure reliable operation of equipment. The NEC does not specifically address ventilation requirements for computer labs, but it's crucial to follow manufacturers' recommendations and industry best practices for ventilation and cooling. Regular inspections and maintenance of electrical systems in computer labs are essential to identify and address potential problems before they lead to failures or hazards. Inspection should include checking for loose connections, damaged wiring, and malfunctioning equipment. In summary, designing and installing electrical systems for computer labs requires careful consideration of the specific requirements outlined in the National Electrical Code and other relevant standards. By following these guidelines and best practices, you can ensure the safety and reliability of the electrical system and protect valuable computer equipment from damage. Remember to consult with a qualified electrical professional for assistance with complex electrical installations and to ensure compliance with all applicable codes and regulations. Proper planning, design, and installation are essential for creating a safe and efficient electrical system for computer labs and other information technology environments. Always prioritize safety and follow industry best practices to minimize the risk of electrical hazards and ensure the reliable operation of equipment. Keeping up to date with the latest edition of the National Electrical Code and local regulations is crucial for staying informed about changes in electrical requirements and best practices. The electrical field is constantly evolving, and it's important to stay current with new technologies, standards, and safety practices. Consider attending electrical training courses and seminars to enhance your knowledge and skills and to stay informed about the latest developments in the industry. Remember that electrical work can be dangerous, and it's important to take precautions to protect yourself from electrical shock and other hazards. Always to energize circuits before working on them, use appropriate personal protective equipment, and follow safe work practices. If you are not qualified to perform electrical work, it's best to hire a licensed electrician to do the job. Safety should always be the top priority when working with electricity. Finally, remember that the information provided here is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrical professional for assistance with specific electrical projects and to ensure compliance with all applicable codes and regulations. The NEC Article 645.5 BONEB is specific about calculating the minimum load for branch circuits. It states that for branch circuits supplying multiple computer receptacles serving a total of more than 10 personal computers, the minimum load must be 125% of the connected load. This means you must calculate the total ampacity of all the computers connected to the branch circuit, and then multiply that value by 1.25 to determine the minimum ampacity rating of the branch circuit conductors. This accounts for the sustained use and potential fluctuations in power consumption of the computers. For instance, if you have 30 computers, each with a nameplate rating of 2 amps, the total connected load would be 60 amps. Multiplying this by 1.25 gives you 75 amps. Therefore, the branch circuit supplying these computers must be rated for at least 75 amps. Selecting the appropriate wire size is also crucial. You need to refer to NEC Table 310.16 to determine the correct conductor size based on the ampacity rating and the insulation type of the wire. For example, if you are using copper conductors with THHN insulation and the ambient temperature is within the specified range, you might need to use a size 4 American wire gauge conductor for a 75 amp circuit. Remember to also consider voltage drop, especially for long branch circuits. Excessive voltage drop can cause equipment to malfunction and reduce efficiency. NEC Section 210.19 AM provides guidance on voltage drop limitations. Aim for a voltage drop of no more than 3% for the branch circuit and 5% overall from the service entrance to the furthest receptacle. Furthermore, proper overcurrent protection is essential. The circuit breaker or fuses protecting the branch circuit must be sized appropriately to protect the conductors from overloads and short circuits. The overcurrent protection device rating should not exceed the ampacity of the conductors it protects, as specified in NEC Section 240.4. It's also important to ensure that all computer equipment is properly grounded, as required by NEC Article 250. Grounding helps to prevent electrical shock hazards and provides a path for fault currents to return to the source. Use a grounding electrode system and connect all exposed non-current carrying metal parts of the equipment to the grounding system. Installing surge protection devices, or SPDs, is highly recommended to protect sensitive computer equipment from voltage surges caused by lightning or other electrical disturbances. SPD should be installed at the service entrance and at the branch circuit level to provide comprehensive surge protection. Consider the layout of the computer receptacles and ensure that they are properly spaced and easily accessible. Avoid overloading individual receptacles and use appropriate wiring methods to connect the receptacles to the branch circuit. In addition to the electrical requirements, consider the environmental conditions in the computer lab. Proper ventilation and cooling are essential to prevent overheating of the equipment and ensure reliable operation. Follow manufacturers' recommendations for ventilation and cooling and ensure that the room is adequately ventilated. Regular inspections and maintenance of the electrical system are crucial for identifying and addressing potential problems before they lead to failures or hazards. Check for loose connections, damaged wiring, and malfunctioning equipment on a regular basis. Always consult the latest edition of the National Electrical Code and local regulations for specific requirements and interpretations. The electrical field is constantly evolving, and it's important to stay current with the latest codes and standards. Seek guidance from a qualified electrical professional for complex electrical installations and to ensure compliance with all applicable codes and regulations. Electrical work can be dangerous, so always take precautions to protect yourself from electrical shock and other hazards. To energize circuits before working on them, use appropriate personal protective equipment and follow safe work practices. If you are not qualified to perform electrical work, hire a licensed electrician to do the job. Remember that safety should always be the top priority when working with electricity. By following these guidelines and best practices, you can ensure the safety and reliability of the electrical system in a computer lab and protect valuable computer equipment from damage. Always prioritize safety and follow industry best practices to minimize the risk of electrical hazards and ensure the reliable operation of equipment.